Welcome back. In this video, we're going to be talking about isotopes, which is section 5.4 in your textbook. And our goals are to explain what an isotope is and how it differs from what we've learned so far. And then if you're given an isotope for any element, we want to be able to talk about things like its nuclear symbol, the number of protons and neutrons, as well as its atomic number and mass number. And then finally, we want to be able to identify the features of Dalton's atomic theory that are no longer considered valid and be able to explain why. That's actually what we're going to start with. So more than 100 years after Dalton's atomic theory was first suggested, another of its features was shown to be incorrect. And if you go back to a previous video when we talked about Dalton's theory, we talked about that one of the things that was considered accurate at the time was that all of the atoms of an element are identical. And that's actually not really the case. Some atoms of an element have more mass than other atoms of the same element. And the differences are called isotopes. That's what we're going to be talking about. So this is a key, though, that the number of protons, okay, for any given element doesn't change, okay? And the number of protons is called the atomic number, which is represented using the symbol Z, okay? And I don't make the rules. I'm not sure why Z is chosen as a symbol here, but it's what somebody came up with, all right? So the atomic number, the symbol is Z, okay? And every atom of a particular element has the same number of protons. And for a neutral atom, the number of electrons is the same for the number of protons. And so if elements then can have different masses, right, of a particular element. So I can have a carbon atom, let's say, with a different mass than another carbon atom, then, and we'll see that in a second, what's really changing then, or what must be changing, is that the number of neutrons is changing within the within the atom, okay? So the number of neutrons is what's causing the different masses in these atoms of the same element, okay? So let's dive into this a little bit more. So an isotope is identified by its mass number, okay? So its mass number is simply this. It's the number of protons plus the number of neutrons, okay? So the mass number uses the symbol A. So you could say A is equal to Z plus number neutrons, okay? So let's now talk about how we can name isotopes given this knowledge, because it plays into that. So for naming an isotope, the name of any isotope is its element name followed by its mass number. So for example here, we have what is the name of a carbon atom with 6 protons and 6 neutrons? Well, we know that A, okay, or its mass number is equal to 6 plus 6, okay, 6 protons, 6 neutrons, excuse me, so 12. So this compound is going to be called carbon 12, okay? That would be the name of this particular isotope. It would be the carbon 12 isotope, okay? So let's do some more examples together. What is the name of a carbon isotope with 7 neutrons? Well, again, if we just go back to our formula, A is equal to 6, because remember the number of protons isn't going to change. All that's changing is the neutrons. This is 13. This is going to be carbon 13. Okay, so again, that's how you're going to name isotopes. You take its mass number, and you basically just put it on the end of the name of the element. Easy. Okay. And here's your example of those two compounds. So this is carbon 12, And then if I added one extra neutron, I gave it 7 neutrons, this would be a carbon-13 atom, okay? So again, differences in isotopes or atoms of the same element differ in their number of neutrons, and these are an example of isotopes, carbon isotopes. Okay, so another way we can represent isotopes is by a nuclear symbol that has the following form. So here, SY represents the element symbol, okay? And so on the top here, you put the number of protons plus the number of neutrons, or its mass number, or the symbol A, however you want to think about it. That goes on the top here. And then the number of protons for the element goes on the bottom. Okay, you could also think about it as its atomic number or Z, okay? They're all kind of the same idea of thinking about it. So pick one that you like, stick with it. It's all good. So what are the nuclear symbols then for these elements for carbon-12 and carbon-13? Or actually, I should say isotopes. They're the same element, different isotopes. So what are the nuclear symbols of these isotopes? Okay, so if we just follow the rules, so we're going to write down its element symbol here, which again is represented by this SY, okay? On the bottom here, it's going to be its number of protons, and on the top is number of protons plus neutrons. Well, let's see here. So we recall that the number that goes on the bottom, or excuse me, the number that is after the isotope name is the number of protons plus the number of neutrons, okay? And remember, if you go on a periodic table, and this is how you'll do these examples in the homework, okay, you'll see that carbon has 6 protons. And the way to tell how many protons something has, if you have a periodic table in your book, it is the, I guess you could say, the number on the top, I think, if you have the same periodic table that's out of the front of your book. Okay, so that red number right there is the number of protons. And we're going to be talking about the periodic table in a video coming up. So if that's a little bit confusing to you right now, just watch all the videos and then come back and watch here talking about isotopes. But we know carbon has 6 protons, and we just did that example. So again, we have 6 protons plus something is 12. This is the same example I did. I'm just writing it out so you see how we would do this. Okay, so this first example is going to be 6. So for carbon-12, the number of protons is 6. This is going to be a 12. For carbon-13, this is still going to be 6. This is going to be 13, okay? So again, the number of protons doesn't change. It's the number of neutrons. So this is what's changing, okay? So it's always 6 though. That's the key. This can change. Okay. This is fixed. All right, so let's do some more examples. So here's a really big table. So fill in the blanks of the following table. And why don't you pause the video and do this, but before you do that though, the number on the top of each box in the periodic table right here, so this is an example of oxygen, is the atomic number of the element whose symbol is in the middle of the box, okay? So the atomic number for oxygen is 8, okay? So with that knowledge, this is kind of what I just said in the previous slide. I forgot I gave this example actually on this slide. Let's fill out this chart together. So pause the video. I'm going to go through the chart kind of quickly. And then if you have any questions, feel free to reach out to me and let me know. Okay. So assuming that you pause the video, let's start at the top here. So barium, if you look on the periodic table, you can get an element symbol, but it's also right here, okay? Because our nuclear symbol for barium is given. So its element symbol is capital B, lowercase a. Its atomic number, well, we can get that right here It's listed on the bottom here of the nuclear symbol. So that is 56. Remember, the number of protons equals the atomic number. So that's also 56. The number of neutrons is 138 minus 56, right? So when you plug that in your calculator, I'll just erase this. 82, I think. I'm pretty sure my math is right here. Okay, so its mass number, well, that's on the top of the nuclear symbol here. So when we do that, it's 138. Okay, and then its isotope name is going to be its element name followed by its mass number, barium 138. Okay, so oxygen, its element symbol. All right, so its element symbol is here. Its atomic number, you could check a periodic table. It's the number on the top of the box. Just so happens to be listed here already. It's going to be 8. Number of protons equals the atomic number, 8. Number of neutrons it's giving us here is 10. So its mass number is going to be 18. I don't know why I wrote that. I have it all animated. Okay, but 8 plus 10 equals, okay, so I'll put this here, plus equals. I don't know if that helps. Isotope name then is going to be, oh, I'm sorry, nuclear symbol. I didn't have that here. So we put the atomic number on the bottom, mass number on the top, and then the isotope name is oxygen 18. So hopefully you got a lot of these when you were doing the example on your own. Okay, so I'll just erase this so it's less confusing now. It's going to get a little crowded here. Okay, this one's a little trickier. Its atomic number here is 82. It doesn't really give us any information. But remember, the number at the top of the box in each box in the periodic table is for a specific element. So you need to go to element number 82 on the periodic table. And when I do that, I get lead. Okay? And its element symbol is capital B, capital P, lowercase b. Atomic number is the number of protons. Okay? And we're given its mass number here, so we just do a little subtraction, and we can get the number of neutrons. Finally, we can write down its nuclear symbol. Again, protons on the bottom, mass number on the top. Its isotope name is going to be lead 206. Okay, finally, so working backwards, we have the element is zinc. It's listed here already. Its element symbol, we could look at that at a periodic table. We can find its atomic number on the periodic table. Number of protons equals the atomic number. Now here, this is its mass number, right? So if we wanted the number of neutrons, we're going to do 66 minus 30, or 36 neutrons. Its mass number is listed at the end of the isotope name, 66. And then its nuclear symbol is going to be shown here. Okay, like I said, I went fairly quickly through that example, but I hope you did it on your own and then you check the answers. And in the next video, I think we're going to be talking, let me see, let me turn my notes here. We're going to be talking about atomic mass. So digging more into this question about the different elements before we talk more about the periodic table. So, see you then.